Hi, my name is Ababa Brahani, and with me here is my co-author Safer. Welcome to our video presentation of our paper, which is titled The Dark Side of Dataset Scaling. Scale the model, scale the data, scale the GPU farms has become a proliferating sentiment in the world of machine learning. We encounter claims such as scale beats noise from prominent and influential papers coming out of big tech labs, as you can see from the screenshot here, where dataset scale is presented as a solution to a multitude of problems, from model performance, bias, to generalization. And this can be observed also in the popularity of the field-wide concept of scaling loss, where large scale is often juxtaposed with better model performance, success, progress, improvement, and so on. However, such claims are rarely supported by rigorous evidence. And the downstream impacts of scaling pre-training data on model performance is an underexplored area. And in this study, we investigate the effect of dataset scaling on racial and gender bias in model predictions. And in order to do that, we evaluated here 14 visual linguistic models that are trained on two datasets, the line 400 million and the line 2 billion datasets, by measuring racial and gender bias. In order to do that, we used the Chicago Face dataset as a prompt dataset. The CFD is an academic dataset that is highly controlled, and it consists of images of 597 individuals along with their self-classified race and gender, with 4 races, which are Asian, Black, Latin, and White, along 2 gender categories, male and female. We passed these 597 images of different genders and races through the CLIP models, providing 8 classes for these models to select from, 7 of which are taken from OpenAI's experiment, which I will explain in the next slide. And what we expect ideally is all genders and race subcategories would be predicted as human being. But again, as we can see in the results in the coming in a couple of slides, that wasn't the case. As our work is inspired by OpenAI's CLIP paper, our methodology and experiments closely resemble the original CLIP paper. We follow their own procedures. And the authors from the original CLIP paper evaluated the CLIP model on a classification task using the Fairface dataset as a probe. And as you can see here, highlighted in yellow, they had 7 classes added. And these classes are animal, gorilla, chimpanzee, orangutan, thief, criminal, and suspicious person. So what we did was verbatim extract these 7 classes, and we added one of our own class, which is human being, resulting in total of 8 classes. We then passed these 597 images through these models. And some of the findings are as follows.
Hi, this is Seper, and I'm presenting the experimental results section. In the results section, we demonstrate the effect of dataset scaling on predicting images as criminal. Columns show ethnicity and rows show gender. We can see that for CLIP VITB32, which is a relatively small model, the probability of getting predicted as criminal decreases by scaling the dataset, which is a good news. But these small models are not so popular anymore since other larger models with higher performance are available. So in this slide, we show the results of audits on one of the larger models, which is CLIP VITL14. Here, the probability of predicting a person as criminal increases by dataset scaling for all the gender and ethnicity subgroups, especially for Latin men and Black men. This increase is almost 70%, which highlights the effect of dataset scaling containing more racial biases in the decision of these large models. We also investigated the effect of models' patch size on criminal prediction on both Leon 400 million and Leon 2 billion. On Leon 400 million, in the most of the cases, higher patch size leads to higher probability of predicting as criminal. However, on Leon 2 billion, the trend is not generalizable for all the subgroups, but for women with different ethnicities, the probability of getting labeled as criminal decreases by having a higher patch size. More experiments and details are presented in the paper. Thank you.
We supplement our quantitative findings with some qualitative analysis. Decades of systemic racism has resulted in somewhat unrealistic depictions of Black people, more particularly of Black men as thug, criminal, and suspicious. And contrary to this Black as a criminal stereotype, a robust body of work, especially in the context of the US, documents that Black men commit crimes at a far lower rate than whites. Black people also constitute the group that are victims of violent crimes as far as at a far higher rates than whites. And for example, innocent Black people, according to Gross et al., are 7.5 times more likely to be convicted of murder than whites. And convicted Black people are 80% much more likely to be innocent than other convicted murderers. And our findings confirm this trend. As you can see from the slide here, each image shows the criminal prediction score for 3 different model architectures and two pre-training data sets. And we observe a trend in the small and larger models. For the larger models, the probability of a Black man being classified as criminal increases as training data set gets bigger. For large models, it was close to 100%, meaning that all the Chicago-Fist dataset samples for Black men were predicted as criminal. Whereas in smaller models, the probability of criminal prediction decreases with dataset scaling. But the problem is, as the field becomes more and more obsessed with scale, people are just not using these smaller models anymore. So to conclude, we list a number of recommendations. I hope you read all the details in the paper. So for example, dataset curation hyperparameters such as the value of cosine similarity embedding vectors tend to be chosen with very little rigor and justification. So given these decisions have significant consequences for dataset quality, but also subsequently for model performance, which can potentially impact concrete lives through model deployment, our recommendation is that dataset curation processes be rigorously justified, well documented, and made transparent in accordance with scientific practices. Thank you for listening.